Okay, Cappuccino, we are going to do some matrix multiplication. So I'm going to start out with an example that is in a context so that kind of makes sense why we would even do matrix multiplication. And then we'll do one that's decontextualized just to show you how to manipulate the numbers. So you'll have a second example. Okay, so here we have drink sales at the Mustang Cafe. And I was going to give you the drink sales for an entire week, but I thought, oh my gosh, that's just way too much work. So I cut it down to Saturday and Sunday. So on Saturday at the Mustang Cafe, they sold 28 Frappuccinos, 32 cappuccinos, and 16 iced coffees. And then on Sunday, there were 34 Frappuccinos, 51 cappuccinos, and 8 iced coffees. And then here are the prices for the drinks. So what we want to find out now is how much money they made on these days from these drinks. Okay, we want to find out what the money was that they made. So on Saturday and on Sunday, we want the total amount of money. So if I want the total amount of money made on Saturday, then of course I'm going to have to do 28 times 4 for the money from the Frappuccinos, 32 times 350 for the money from the cappuccinos, and 16 times 250 for the money from the iced coffees, and then add those together. That will get me the amount of money made on Saturday. For Sunday, I'll do the same thing. So to get the total money for Sunday, it would be 34 times 4 plus 51 times 350 plus 8 times 250. And that, my dear students, is matrix multiplication. That's all it is. When you take a grid of information and multiply it by another grid of information. Okay, so I am going to set this up like a matrix now. To make it look like a matrix, we're going to put it in parentheses, giant parentheses or brackets. Okay, so here's my first matrix. And notice if we were to say the order of this matrix, it is a 2 by 3. There are 2 rows and 3 columns. So it's a 2 by 3 matrix. And then this one over here, I can make it into a matrix. This is a column matrix because there's only one column. So we call it a column matrix. And if I write down its order, it's 3 rows by 1 column. So it's a 3 by 1. And remember, the order that you write these numbers is of critical importance. You cannot switch them. It's not okay to do that. Okay, so if I'm going to multiply these together, I am then going to get my revenue for the 2 days. So my revenue, the amount of money I'm bringing in, if you remember our business calculus. So my revenue for Saturday, we'll start with Saturday. My revenue for Saturday is going to be equal to 28 times 4, times that $4, plus 32 times 350, plus 16 times 250. So if I put that into my handy dandy calculator, I would get a total of $264. So that's how much money I made on Saturday. So for Sunday, the revenue from Sunday would be 34 times 4 plus 51 times 350. Okay, 51 cappuccinos times 350 plus 8 iced coffees times 250. And again, if we put that into our handy dandy calculator, we're going to get $334.50. And this is our outcome for each day. So what I just did is this is matrix multiplication. I took a matrix that was 2 by 3. I multiplied it by a matrix that was 3 by 1. And my resulting matrix, oops, right on the edge of my paper here, ended up being 2 by 1. So notice when I multiplied these 2 matrices together, I ended up with a matrix of a completely different size. So that's quite possible to happen. So there's kind of a rule for when you multiply matrices together. In order to be able to multiply them together, they have to meet this one rule, which is, notice this was 2 by 3, and I'm multiplying it by a 3 by 1. these dimensions have to be the same. So the first matrix, its number of columns has to be the same as the number of rows on the second one. So if I write this out, that I had my, how do I want to write this out? I had a 2 by 3, and I'm going to multiply, or times, by a 3 by 1. The rule here is that these have to be the same. These have to be the same. So the inside numbers have to be the same. And then notice the result is a 2 by 1. So the outside numbers then will give you the size of the resulting matrix. Okay, so the size or the order of the resulting matrix. Okay, so this is what you want to look at. When you're asked to multiply matrices together, you need to look at the sizes and see if it's even possible. Okay, so if this had been, if I didn't have the price of the iced coffee, right? If this had just been a 2 by 1, if I didn't have that, if this had been a 2 by 1 and I didn't have the price of the iced coffee, I wouldn't be able to do anything with that 16. I wouldn't know what to do with it. So it's really important that this number be the same as this number. I have 3 items going across this way. So I have 3 columns going this way. So I got to have 3 rows this way because I need to have 3 numbers to multiply with these 3 numbers. Okay, so that's why these numbers have to be the same. Because if I didn't have this third one here, and then I went, you know, I did my 28 times 4, my 32 times 350, well, what am I going to multiply the 16 by? Okay, likewise, if I didn't have my 3 rows, what if it had just been 2 rows and I had 3 numbers here? Well, what am I going to do with that? Okay, so these numbers need to match up. The number of columns of the first matrix has to match with the number of rows of the second one. And so here's a real easy way of doing it. Just take the order of your matrices next to each other, see if the inside ones are the same, then you can multiply them. And the result is going to be the outside ones. All right, so let's go ahead and do a decontextualized example. And by the way, you'll get a chance to practice that in MathSpace. Oh, what happened here? My notebook is full. Holy cow, I need to get a new notebook. Oh my gosh, right in the middle of a video, I've discovered that my notebook is full. Good thing I have more notebooks. So let me grab a new notebook. Okay. Holy moly, I did not see that coming. All right, second example. So here we're going to do one without a context. So this one I'm going to have matrix A is going to be, let's get this closer to me so I copy it right. I'm going to have 1, -1, 5, 4, -3, and 2. And I'm going to have matrix B, which is going to be equal to -1, -3, and 2. And then 2, 4, and 1. So here are my 2 matrices, A and B. So notice the order of A is 2 by 3. This is a 2 by 3 matrix. And this one is a 3 by 2. So if we analyze these, right, the middle ones need to be the same. This is the same. So that means, yes, I can multiply them together. So I'm going to go ahead and multiply these. I'm going to do A times B, matrix A times matrix B. And I'm going to show you all the work. I'm going to write it all out. Okay, so just like I did with my frappuccinos, you know, my drinks, I'm going to multiply these 3 numbers here in my first row are going to get multiplied by the first column over here. So I'm going to have 1 times -1, and I'm going to add that to 5 times -3, and I'm going to add that to -3 times 2. So I'm multiplying the first row with the first column. And that's going to be my first entry in my matrix. And notice the resulting matrix is going to be a 2 by 2. Okay, so over here, I'm going to do again the first row but this time with the second column. So I'm going to have 1 times 2 plus 5 times 4 plus -3 times 1. There's that one. Okay, now I'm going to go to my second row, and I'm going to go and multiply it with the first column again. So my second row here, -1 times -1 plus 4 times -3 plus 2 times 2. And then I'm going to do the second row with the second column, and it's going to go over here. -1 times 2 plus 4 times 4 plus 2 times 1. Okay, so there it is. There is my resulting matrix. Okay, so I'm going to have, here's my matrix. So then I just need to simplify this. So I'd put it into my calculator and simplify that, and my resulting matrix, AB, is going to be, this first one equals -22. This one right here equals -7. This one up here equals 19. And this one down here equals 16. So here is my resulting matrix. And notice it, in fact, is a 2 by 2 matrix. 2 by 2. Okay, so what about if I wanted to find BA? What if I wanted to find BA? What if I wanted to multiply B first and then A? So is that the same thing? So find is, I'm going to ask a question, is BA equal to AB? Can I reverse the order? Like 2 times 3 is equal to 3 times 2, right? Multiplication is commutative. Is it commutative for matrices? So are those equal? So let's go ahead and flip these then. What if I write the B first? So I have my B is equal to, that's going to be my first matrix, -1, -3, 2, and then 2, 4, and 1. And then I'm going to multiply that by matrix A, which of course is 1, -1, 5, 4, -3, and 2. So doing what we did up here, let's see, can we even multiply them together? Let's have a look. So this one is 3 by 2. Okay, 3 rows and 2 columns. This is a 3 by 2. And this one, there's 2 rows, 2 by and 3 columns. Okay, so can I multiply them together? Yes, I can multiply them together. The inside numbers, number of columns here and the number of rows here is the same. So these, I can multiply them together. But what is my result going to be? The result is going to be a 3 by 3. The result when I did A times B was a 2 by 2. But if I multiply B times A, I'm going to get a different size matrix. It's going to be a different size. Okay, so the result here, the result is 3 by 3. So therefore, they are not equal. A times B does not equal. It is not the same as B times A. So the commutative property does not work for matrices. The order is critical. So if you're asked to multiply matrix A times matrix B, you're going to get a different answer than if you're asked to multiply B times matrix A. You're going to get a different answer. I don't even have to do the work because I can see that the size, I'm going to end up with a 3 by 3. I'm going to end up with 9 values rather than 4 values. So therefore, it is not commutative. Okay, so multiplication of matrices is not commutative. You cannot switch the order. Okay, it is not commutative. Not commutative. Unlike regular multiplication, multiplication of just numbers, real numbers, is commutative, but it is not for matrices. All right, that's it. Take it away with the math space, and I'll see you on Friday.